wants to design a roller coaster for the fun fair. The first iteration of his model, he approximates the roller coaster as a particle on the surface of a sphere. So we're basically talking about an R value pushing outwards, aren't we? And it's going to be the weight pushing inwards that causes it to go around in a circle. Now, the particle is smooth, so it's smooth around the outside. The particle reaches and rests when it is at angle A to the upward vertical. Angle A is the red one. Angle B is the blue one. Okay, and okay, show that phi squared is 2gr cos A minus cos B. All right, this is just conservation of energy. So what's PE1, lads? Your choice. I'm going to cut it here. So that's going to be my H equals 0. You don't have to do that. I'm going to do it because it makes it easier. You're not going below the halfway belt. Okay? So PE1 plus KE1. So what's PE1, lads? Hard to tell, isn't it? See this blue line I'm shading in here? Anybody care to tell me what it is? R cos A. So it's mg R cos A. Okay. Kinetic energy, guys. Is it let drop, is it? Or is it giving a bit of speed? So what do we think about its kinetic energy? 0. And then PE2. Well, this time it's an angle B instead of an angle A. Do you get what I'm saying? Instead of R cos A, it's going to be R cos B because its height is here. And if you see this little, you see this red line here, that's R cos B in height. So it's mg R cos B, is it? Okay. And have mv squared. Okay. M's cancel, don't they? M's cancel. Multiply both sides by 2 so that we get phi squared because that's what I'm looking for. And then I get 2gr cos B and 2gr cos A. And these were the easiest 10 marks in the exam. Bring 2gr cos B over to 2gr cos A, factorize and separate, and you get 10 out of 10 for that. What we're going to do is part 2, is it? Oh, I haven't got part 2 yet. If cos A is 2 over 3 and Q is the point where the particle falls off the sphere, find the angle B. What do we know about the R value when you fall off the sphere? R value is 0. Now, this is the point at which the R value would be 0. Is that okay? And that's the center of the circle. And we all agreed that it was at angle B, wasn't it, that occurred? Are you all happy that's angle B? Go. Now, I'm going to resolve mg. Here's my mg going downwards. What can I say about this angle here? Right. What can I say about this angle here? B. Why? Huh? Alternate. Okay. Now, let's get this line here. See the line at the bottom, the black line I'm doing there? What do we think? mg cos B. Well done. Look at this. It's mg cos B is aiming towards the center of the circle, isn't it? It's in the same direction as that. So they're both in the same direction. What's in the opposite direction? R. But what do we know about R? It's going to be 0 when it falls off. Okay, so the R doesn't really matter. And then what we're claiming is that that's mv squared over r. Is that okay? Now, r goes away, and what do we have? mg cos b. I'll bring up the r. mgr cos b equals mv squared, yeah? I'm going to look at the last thing we were asked to prove. What was the last thing we were asked to prove? We're asked to prove this here, weren't we? I could just put an m back on that again, couldn't I? I could say this. Sorry. Yeah, I will do in a second. Everybody cool with that? I'm going to grab that. I'm going to bring it back in here. Now, what do we think? Cos b, yeah? And I'm just going to rub this out, and what am I going to say equals? mgr cos b. I'm a bit silly because I was told what cos A was, wasn't I? Cos A is. So what can I do there? 2 over 3. And by MGRs, yeah? Gone. So 4 over 3 minus 2 over 3 cos B equals cos B. What happens when I add 2 over 3 to cos B? What do we get? When I bring it over to your side. 5 over 3. Now what does that mean cos B will be then? Cos B will be 4 over 5. And what happens when you cos inverse 4 over 5? Anybody? Well, did I make a mistake? Yeah, I made a mistake here, guys. Just 1 second. Somebody's going to tell me where this happened. So I'm going to come back up here for a second. What you say I made the mistake of? Oh, there was no 2 over 3. It's just 2 cos B, is it? And that was just cos B. And that gives me 3 cos B 4 over 3, isn't it? Ah, that's more familiar. Cos B is 4 over 9. And I'm going to inverse that. 63.6 is the correct answer. Thanks, whoever found that.